Now I am going to read the question number 26. A body cools from 100 to 90 in 10 minutes and from 90 to 80 in 15 minutes. The temperature of surrounding is. This question based on Newton's law of cooling, and in this type of question we can apply the approximation method. And you know very well, if any body is cool from T1 up to T2 in time T, then we can write T1 minus T2 upon time with constant K, T1 plus T2 divided by 2 minus temperature of the surrounding. So this is the approximation method. In this question, T1 is 100, T2 is 90 and time T is 10 minutes. So you can solve this question by using two methods. So first I will write the value of T1 is 100 and T2 is 90, time T is 10 and K, T1 plus T2, 100 plus 90 divided by 2, and I need the temperature of the surrounding. Right? So this is my relation number 1. And now I am going to take second condition. In this time, T1 is 90, T2 is 80. So we'll write 90 minus 80 and time T is 15 minutes. Constant K, 90 plus 80 divided by 2, temperature of the surrounding, and this is my relation number 2. But I need to calculate T0, so I am going to divide equation 1 by 2, because you know 100 minus 90 is 10, 90 minus 80 is 10, so it will cancel out, ये cancel हो जाएंगे. लेफ्ट हैंड साइड में आपको मिलेगा 15 upon 10 and kk will also cancel out and T0 is there. So on solving we'll get, when you will solve 100 plus 90 divided by 2, so we'll get 95 minus T0, 85 minus T0, because you can solve by dividing equation 1 and 2. And now if I take the cross multiplication, we'll get 255 minus 3T0, that is equal 190 minus 2T0. 2T0 and 3T0, when you will add them, we'll get 5T0. So on solving by this expression, we'll get the value of T0 is 65 degrees centigrade. So in this question, you have to be very careful regarding this approximation method, and this is very important question for the NEET. So on behalf of that, we can say my option number 4 is correct. So let's move on question number 27. So now first I am going to read the question number 27. Figure shown below is graph of monoatomic gas which undergoes a cyclic process. Okay. If work done by the gas in process BC is X, the heat absorbed in the process CA is. So first I am going to take the process B to C, and in this process pressure will remain constant but temperature will change. So this is isobaric process, right? And if I write the formula of work done in isobaric process, that is given by number of mole, ideal gas constant, and temperature difference T0 minus 2T0, because T0 is the final temperature and 2T0 is the initial temperature. So as per the formula in isobaric process, we can make this relation by using this graph. So this is my relation number 1. Now, according to the problem, this work done is given by X. So X is equal to NR, T0 minus 2T0. So minus 2T0 is there. So we can use minus sign here, because T0 minus 2T0 is equal to minus T0. So this is NR T0, and this is my final relation number 1. And if I go for process C to A, C to A is isothermal process, because when I will move from C to A, temperature will not change but pressure will change. So this is isothermal process, and I know heat for isothermal, I am writing here ISO for isothermal, and that is nRT naught log initial pressure and final pressure P naught and 2P naught, because when I will start from C, initial P naught, final 2P naught. But if I want to change 2P naught upon P naught, then we will use a negative sign, right? So if I write this heat like that, minus nR T naught, this is log 2P naught upon P naught, right? So this is my relation number 2. And now I am going to take equation 1 and 2. If I divide equation 1 and 2, so we'll get Q upon X on the left hand side, and on the right hand side, because nR will cancel out, and so we'll write only log 2, because P naught will cancel out, and from this nRT naught will cancel out. So I have the value of only log 2. So Q is equal to X log 2. By this calculation, I have X log 2, because minus and minus will cancel out. So on behalf of that, we can say my final answer is option number 1. So now I am going to take question number 28. Select the correct option. A hotter body has more heat contained as compared to colder body. No, this is not true, because the temperature difference will decide the flow of heat. Because if I take a simple example, suppose if I say I have 2 water containers. One container is at 100 meter height, for example, and second container have only 0 height, means it is placed on the ground. And if I open the valve of the water, and if I say this is water tank number 1 and this is water tank number 2, and if I ask you, tell me the direction of water flow, then your answer will be 1 from 1 up to 2. But this is not correct, because I am saying only this is the water tank. I am not saying filled with the water. So water will flow if there is water. So height difference will not decide, will not give, कोई ऐसी guarantee नहीं देता कि water flow करेगा. He can decide only the direction of flow of water. Water होगा तो जाएगा, क्योंकि this is a water tank. I am not saying filled with the water. In the same case, if any container of the gas having 100 degree centigrade of temperature and 20 degree centigrade of temperature, if I connect them and if I ask you, tell me the direction of heat flow, then your answer will be from 100 up to 20. But मैं ये नहीं कह सकता कि heat energy flow करेगी, because अगर इस कंटेनर में heat energy होगी तो 100 से 20 फ्लो करेगी. बट टेम्परेचर डिफरेंस इस बात की गारंटी नहीं दे रहा है कि हीट होगी. हॉटनेस एंड कोल्डनेस जस्ट लाइक द हाइट डिफरेंस, बिकॉज अगर कंटेनर में गैस है तो ड्यू टू द टेम्परेचर मॉलिक्यूल्स ऑफ द गैस विल इंक्रीज अवर काइनेटिक एनर्जी एंड दे विल कोलाइड एंड प्रोड्यूस द हीट. If there is no gas, then there is no collision, then there is no production of heat. So meaning of that, a hotter body has more heat contained as compared to colder body. This is not correct statement. So option number 1 will not be correct. And if I go option number 2, heat always refers to energy in transit from one system to other. Yes, this is correct. So option number 2 is correct. But if I go for option number 3, a process is possible whose sole result in transfer of heat from colder body to hotter body. No, this is not correct. And we cannot make heat flow from body at lower temperature to body at higher temperature? No, because this is possible by taking the source of energy. अगर मैं यहाँ पे एक मोटर पंप यूज करूं तो मैं इस वाटर को लोअर साइड से अपर साइड में ले जा सकता हूं. सेम केस जैसे रेफ्रिजरेटर आप पढ़ते हो, हीट को अपोजिट साइड में हम चला सकते हैं बाय यूजिंग हीट इंजन. तो मैं ये नहीं कह सकता वी कैन नॉट मेक हीट फ्लो फ्रॉम body at lower temperature to body at higher temperature. We can do that by using heat engine. So option number 4 is not correct, option number 3 is not correct, and 1 is not correct. The final choice is option number 2. So let's move on question number 29. Now I am going to take question number 29. At what temperature of the reading centigrade scale and Fahrenheit scale are in the ratio 2:3? So we know the relation between centigrade and Fahrenheit is F minus 32 upon 9. According to the problem, because centigrade scale and Fahrenheit scale are in the ratio 2:3, so let's consider the value of C is 2x upon 5. And F is equal to 3x because ratio is 2:3 minus 32 upon 9. If I take cross multiplication, 18x 15x minus 32 into 5. So 18x and this is 15x, on solving will get 3x is equal to minus 160. So x is equal to minus 160 by 3. So I have x is equal to minus 160 by 3. So if I go for centigrade scale, according to the problem 2:3, so this is 2x, and if I place the value of x minus 160 by 3, so we'll get minus 320 by 3 degree centigrade in terms of centigrade. So we can say my option number 3 is correct. And let's move on question number 30. So I'm going to take the question number 30. A refrigerator based on Carnot cycle receive heat from 227 degrees centigrade, reject heat at 727 degrees centigrade. Let the work input required per unit heat received is X. If the same machine is used as a Carnot engine, then its efficiency is Y. The ratio of X and Y is. So first I am going to take for the refrigerator. So for refrigerators, X is equal to the work and Q2. Similarly, if I take for the engine, so I will write Y and that is work to Q1. X is W upon Q2, and for the engine Y is equal to W upon Q1. To find X upon Y, so I am going to take a ratio X upon Y, that is Q1 upon Q2, and you know Q1 is T1 upon T2. As per the question, T1 is 727 plus 273 and T2 is 227 plus 273. So we'll get X upon Y is equal to 2, because this is a simple calculation, so you can do it, and X upon Y is equal to 2. So we can say my option number 1 is correct. Let's move on question number 31.